All right, next up, if we could have Sara Dumit, who joined the Washington State University Pharmaceutical Sciences doctoral program in 2014 and USTUR in 2015. Her talk is going to be on case 785, modeling plutonium decorporation following complex exposure.
Good morning. Thank you for your presence. Um, and thank you for the opportunity, Dr. Sergey, to be at the USTUR. I'm very grateful. Okay, so today I'll be talking about the USTUR case 0785, modeling plutonium decorporation following complex exposure. Okay. So for this project, the objectives were to model plutonium biokinetic under decorporation treatment and to estimate intake and dose. So to give a summary, compile information from the USTR database from the records. This individual was exposed to plutonium via acute inhalation and wound. And the records say the material type was M, but I put in parentheses it was assumed and later on we found out it was not type M. So this individual was a smoker for about 38 years and he passed away from lung disease, 51 years post-intake at the age of 79 years old. And this individual was performing his routine professional duties at the Defense Nuclear Facility. While a glove box explosion happened, he was working with plutonium nitrate solution. He had contamination on face, hair, neck, and forearms with a facial wound deposition of 8,032 becquerels. And the work site estimated plutonium systemic burden of 7,400 becquerels, which is 5 times higher than maximum permissible body burden. So how did they treat him? So the strategy was divided in two parts. So first they give the decorporation or chelation agents immediately, 1 to 2 grams of calcium EDTA twice per day intravenously for 4 weeks, and 9 months post-accident, and 7 years post-accident, but zinc DTPA this time, and for 10 weeks. And the second strategy was a wound excision, so tissue excision, 3 weeks post-accident, about 7,344 becquerels of plutonium was removed. So regarding the bioassay measurements, we had in the records in vivo 74 lung counts. You can see the graph on your left. And in vitro, 478 urinalysis. So these are plutonium-239 activity in lungs by time post-exposure, about 16,000 days. And also on your right, you can see how extensive was the urine analysis, almost 500 measurements. Those peaks you can see where the treatment was applied in the bottom, so high excretion of plutonium activity in urine. Okay, so regarding autopsy tissue analysis, we had total of 32 tissue samples for this case, and 238, 239, and 240 plutonium concentration measured, and also total tissue organ activity estimated. So this table is just a brief summary. You can see the tissues, organs, and the plutonium concentration, and also the plutonium activity, for example, lungs, lymph nodes, liver and skeleton, and total systemic. So you can see total systemic was 2,728 becquerels of plutonium activity, and you can see majority deposition in skeleton, then liver and lymph nodes and lungs. So very interestingly, we were doing the concentration ratio between lymph nodes and lung as a confirmation for the material type, which was from the records, a material type M. So we were expecting a ratio to be 1. But to our surprise, the ratio was much higher, so 323. So we had to change the assumptions of material type M to what the number was telling us, actually exposure to very insoluble materials, so what we call super S, so very slow absorption rate. And regarding data analysis, the biokinetic models I used, ICRP, Human Respiratory Tract Model, ICRP 130, and NCRP wound model, NCRP 156. So remember, his exposure was complex exposure, which means through inhalation and wound. So that's why I'm considering both models. And systemic from Leggett, plutonium systemic model. So we used the ICRP default assumptions, except for particle size, which due to the high explosion, small particles are created. So we are assuming 1 micrometers for the diameter. And as I explained the slide before, lung absorption type S, not M, and wound retention category insoluble colloid. So the software I used was IMBA Professional Plus, which you probably know very well about this software. It's very famous in suite of software modules for internal dosimetry, and comes implemented with all current biokinetic and dosimetric models, which enables the user to, for example, predict bioassay quantities from a specific intake, calculate resulting dose. You can see these little pictures in the bottom as in illustrations of the models implemented in the software. Okay, so the software was applied to fit postmortem data, simultaneously fitted lung and urines. Here you can see the lung and the plutonium activity by the time of post-exposure. And here is urine. I had to divide it in 3. As you saw my graph, it was pretty extensive, so almost 500 measurements, and the software didn't allow me to fit everything in one graph, so I had to break, but all the data is there. And regarding our calculations, we found that majority of the exposure came to inhalation with 33,050 becquerels, so about 97%, and minor part came from wound, so 1,084 becquerels, so only counting 3% of the residual intake estimation. So these are the activity now removed by the chelation therapy. Okay. So total intake and dose estimation here, the intake, the residual intake, as we said in the previous slide, 34,134 becquerels, and I summed up the plutonium removed by chelation, which was 683 becquerels. So total of 34,817 becquerels for this specific case. And regarding the committed effective dose, residual was 1.09 sieverts, and the projected, in case he wasn't treated, it would be 1.11 sieverts. So the conclusions, this individual was exposed to highly insoluble plutonium material. In systemic deposition, 51 years post-intake was 2,728 becquerels, with a skeleton to liver activity ratio of 3:1. And as we said, major internal contamination of 97% from inhalation. And estimated intake was 34,817 becquerels, with estimated committed effective dose of 1.09 sieverts. And major conclusion of this project was that only 2% dose was saved by Decorporation treatment. I would like to thank one more time the USTUR, the team, and many other people who are not in the picture, in the Department of Energy, Washington State University, and these amazing people that help students to succeed. if you have any questions, I'm happy to answer, and I'll be around in case you need to talk more about this. Thank you.
I'm curious, after the accident, was the individual prohibited from future work with internal emitters? Do you know?
Yeah, it was the high dose. So from the records, he was not. He was.
What-
He was removed.
He was what? He was
Removed.
good. That's excellent. That's excellent. Thank you very much.
Thank you, Doctor.
Thank you for a very fine paper.
Okay, thanks.
I also have a question. You had earlier that the patient was treated with 1 to 2 grams of
Yeah.
the DTPA IV. Do you know why 2 grams was used?
Yes, so let me go back to the slide, okay? Okay, so here immediately he actually didn't receive the TPA. Actually, the work site and the medical team decided to give him EDTA instead. So they varied the range of the administration dose for between 1 and 2. I don't know exactly why they decided to do that, but it's expected for EDTA, and you can see expected for DTPA 1 gram only. So that was exactly the strategy they gave him. So
Okay,
yeah.
thank you for the
Okay.
clarification.
Thank you.
I have a question too. So for your modeling, so you assume the assumption that the inhalation of was super S compound.
Yes.
So for the modeling, did you adjust the retention parameters in the respiratory tract for super S?
Yes, we adjust the parameters for considering it was very insoluble material. So we made this change so it could fit our data as expected.
Oh, okay. Thank you.
Thank you. I guess it's red. Okay, thank you.